We are going to discuss simplification of context-free grammars. Simplification of CFGs, context-free grammars. Simplification of context-free grammars. Here, in the simplification, we have number 1, eliminating useless symbols. 2, eliminate Epsilon Productions. And 3, eliminate unit productions. These are the 3 steps you have to take. That is, eliminating unit productions, eliminating epsilon productions, and eliminating useless symbols. See, what is a useless symbol? Useless symbol. If a symbol is said to be useful, so if a symbol is useless, that means it is not useful. A symbol is useful if it is both generating and is reachable. If it is both generating and reachable, that symbol is said to be useful. So what do you mean by generating? Suppose that if a symbol from a non-terminal x, if you can generate a string w, that means a non-terminal x is said to be useful if you can derive a terminal string from that. For example, suppose that a derives abc from this string or from this variable, you are able to derive a terminal string. That means this is a generating one. That means if a terminal string can be derived from a variable. Suppose that you have A derives BC and B derives B and C derives C. So here this BC can be replaced by BC and that can be replaced by BC. That means from A you have generated a terminal string. Okay. If a string can be derived from a variable, that variable is a generating one. It is a generating one. And a symbol is said to be reachable. Reachable in the sense, for example, suppose that you have a string. Suppose that you have S derives AB and C derives BC and D derives AB. Suppose that these are 3 productions and suppose that A is the start symbol. Then from S you can derive, from S you can reach both A and B. Okay. From A you can reach, that means from A, from B also. That means this C can't be derived from S. Why? S derives AB, C derives BC and D derives AB. That means this C cannot be derived as a part of S. From S you cannot reach C. That C is not reachable. What about D? S derives AB and suppose that S derives ABD. Then S derives ABD and D derives AB D and D derives AB. D derives AB means D derives A, B, and D derives AB, and A derives nothing, B derives nothing. That means from S you can reach A, B and D. S derives A, B, D and D derives A, B. Here also C is useless. Why? C is not generating. C is not reachable. Why? C is not reachable from the start symbol. If a variable can be derived from the start string, that means this is reachable. That means a symbol X is said to be is reachable. Symbol X is reachable if S in 0 or more steps gives alpha x beta. That means X is reachable if the start symbol derives X in 0 or more steps. If the start symbol X is reachable if that X is reachable from S in 0 or more steps. That means from the start symbol you should be able to reach. That means in any one of the derivations this X should come. That is why it is reachable. And X is generating if X in 0 or more steps derives W. That means capital X derives in one or more steps W. That means if a string W can be derived from X and a symbol is said to be useful, a symbol X is useful. A symbol X is useful if it is both generating and reachable. If a capital X is useful, said to be useful if it is both generating and reachable. And if it is not useful, that symbol is said to be useless. If a symbol is not useful, that means it is useless. Okay, that means regarding simplification of context-free grammars, now initially we are going to eliminate useless symbols. And when we are talking about useless symbols, you have to know what is a useful symbol. A useful symbol is both generating and reachable. Generating in the sense from that symbol you should be able to derive a string. And this reachable means from the start symbol in some derivation it should come. That means from the start symbol you should be able to reach that symbol. If a symbol is both generating and reachable, it is called a useful symbol. Any symbol which is not a useful symbol is a useless symbol. So I am going to tell you an example, or I will show you an example. S derives AB or A. S derives A, B or A, and A derives B. Suppose that we have a grammar like this. Here S is the start symbol. S is the start symbol. Start symbol is generating and start symbol is reachable from start symbol. What about A? A is reachable from S. Why? From S you have SA. And A is generating B. That means it is both generating and reachable. A is reachable and generating. A is reachable. Why? From S you can reach A. What about generating power of A? A derives a terminal B. That is why it is both generating and reachable. What about B? B is reachable. Why? B is reachable. Why? From S you can reach B. It is reachable. What about generation? Generating. That means from B you are not able to derive anything. So you have B is not generating. Then what you have to do? You have to eliminate the productions in which B is a part. Here S derives AB or A and A derives B. Now if you are removing this AB from here, what will happen? This will go. And what about this? S derives A. That means S derives AB or A. From this, if you are eliminating this AB, S derives AB, what will happen? S derives A. Now A is not reachable, so you have to eliminate this also. That means S derives A. Okay. S derives A and A derives B. But A is not reachable from this, so you have to eliminate this also. S derives A only. This is the way you can eliminate useless symbols. The way you can eliminate useless symbols. And now we are going to discuss what are epsilon productions. Epsilon production. For example, suppose that S derives 0 S0, 1 S1, 0 or 1 or epsilon. Here how many productions are there? S derives 0 S0, S derives 1 S1, S derives 0, S derives 1 and S derives epsilon. Here epsilon product, here one of these productions is S derives epsilon and that is an epsilon production. S derives epsilon is an epsilon production, and the second step for simplification of in the simplification of CFG is we have to eliminate epsilon productions. Epsilon production. How to eliminate this? So here now I have eliminated this. That means I have eliminated this and S derives epsilon. So here you have to replace all these S's with epsilon. Then if you put 0 here or epsilon here, what will happen? You will get another production which is 0 0. And if you put S as epsilon here, what will happen? You will get another production 1 1. That means now after eliminating this epsilon production, now the grammar is this, that is S derives 0 S0, 1 S1, 0 or 1 or S derives 0 0 or I will show you another example. S derives AB, A derives S derives AB, A derives A or epsilon, and another production also is there. B derives B, BB or epsilon. See, this is S derives AB, A derives A or epsilon, and B derives BBB or epsilon. Now, if how many productions are there? S derives AB. Now A derives A derives epsilon. B derives B derives epsilon. Now I am going to eliminate this epsilon production. A derives epsilon. So for that, what I am going to do is you have to search for A's on the right hand side. Here this production is having A on the right hand side. This is also having A on the right hand side. So when you are replacing this A with epsilon, what will happen? This becomes S derives B. When A is replaced with epsilon, this becomes B. And in this production, when you are replacing this A with epsilon, what will happen? It will become A derives A. Now you have removed this. That means A derives epsilon. From this grammar, you have eliminated that. Okay. Now now S derives B, A derives A. Okay. Now if you are eliminating this, what will happen? B derives epsilon. Then you have to look for B's on the right hand side. So this is having B and this is also having B. Then when you are replacing this B with epsilon, what will happen? This becomes S derives A. S derives A and B derives. When this B and B are replaced with epsilon, this will be B derives B. Okay. That means S derives B, S derives A derives A, B derives B. And then you have to replace, you should have S derives AB, then A derives A, and B derives B. So these are the new set of productions. Okay, these are the new set of productions after eliminating this epsilon production. After removing these epsilon productions. Okay, and now we are going to discuss. So that is the way we can eliminate epsilon productions, and now we are going to discuss what are unit productions. See, a production in which the left hand side and right hand side are single non-terminals, that is called a unit production. That means on either side of either left hand side as well as the right hand side is having a single non-terminal. Okay. Now suppose that we have a grammar like this: S derives A derives B, and B derives small b. This is here. This is also unit production, but one side of this is the start symbol, so there is no need to eliminate that, and you are not allowed to eliminate that production. But this is a valid unit production. And now if you want to eliminate this, what you can do is, see the left hand side of the production A, and this is the left hand side, and now you have to search on the right hand sides of all the productions, and wherever there are A's, you have to replace that with B. That means here you are going to eliminate this, and the left hand side of this is A, and you have to replace that with B. That means once you have eliminated this, this becomes, or this is equivalent to S derives B and B derives B. S derives B and B derives B. Okay, this is the way you can eliminate unit productions. This is the way you can eliminate unit productions. So we have been discussing simplification of context-free grammars, and in the simplification of context-free grammars, we have three types of elimination. First of all, you are going to eliminate useless symbols. Then you are going to eliminate epsilon productions, and then you are going to eliminate unit productions. So if you want to eliminate useless symbols, you should know what are useful symbols. A symbol is useful if it is both generating and reachable. Generating in the sense, from that symbol you should be able to derive a terminal string, and reachable in the sense, from the start symbol you should be able to reach that symbol. And what about epsilon production? If the right hand side of a production is epsilon, we call it as an epsilon production. And if you want to eliminate that, look for right hand sides where there are the left hand side of the epsilon production, and you have to replace all those left hand side, all those right hand sides with epsilon. Then you will get another set of productions, and at that point you can eliminate that epsilon. And see, then we are going for unit production. A unit production is a production in which both sides of production are variables, a single variable, and that can also easily be eliminated, and that process also we discussed. And now we are going to discuss what is Chomsky normal. Now we are going to discuss Chomsky normal form grammar. A grammar is said to be in Chomsky normal form. Either the right hand side is having two non-terminals or a single terminal. That means this is the standard form. A derives BC or A derives A means every production should be having either two non-terminals on the right hand side or a single terminal on the right hand side. Suppose that you have a production like, say, A derives B, C, D, and suppose that C derives B, D, and D derives small d. Suppose that we have a set of productions like this, and this is not in Chomsky normal form. Why? This is in Chomsky normal form because the right hand side is a single terminal. So this is in Chomsky normal form, but this is not in Chomsky normal form. Why? Only two non-terminals. If it is having either two non-terminals on the right hand side or a single terminal on the right hand side will be accepted. Okay. Here we are having a terminal followed by a non-terminal. So how will you convert this to Chomsky normal form? I am going to have a new variable TB. That means T subscript B. This is a single entity and TB derives B. This is a new production I have added, and after doing this I am going to replace this B with TB. Okay, that means after that we have replaced that C derives what? TB into D. That means TB is a single variable, T subscript B, TB followed by D. That means now this also is a valid Chomsky normal form grammar. There is no need to have this anymore. That means this is replaced with this. Okay. Now this is also a valid Chomsky normal form grammar. Now we have A derives B, C, D. Now we have B, C, D. Suppose that this is ACD. I am going to have, instead of BCD, I am going to have ACD. Now I am going to have TA derives A. Now I can replace this A with TA. Now A derives what? TA C D. TA C D. Now this also is not in Chomsky normal form because here these are two non-terminals followed by a terminal. Now I am going to replace this TA into C with another expression. Say I am going to have T subscript AC derives TA into C. TAC derives TA into C. That is another production. This is another production I have added. This is also another production. This is the second one I have added, and this is the third one I have added. Now TAC, T subscript AC. This is a single entity. TAC derives TA. Now TAC derives TAC. This is capital C. That is also in Chomsky normal form. And now what is ACD? TACD. Now I am going to replace this TAC with what? TAC. That means A derives TAC. TACD. Now what about D? D derives capital D. So I am going to replace this with D. Now this also is in Chomsky normal form. And now I am going to eliminate this production. We don't have, there is no need of this production anymore. We don't need this, and replace this 3 with these set of productions. That means, anyway, you should remember this thing. That means the right hand side is either a single non-terminal. The right hand side is either a single terminal or 2 non-terminals side by side. So we should know that. So that is all about Chomsky normal form grammar. And at this point in time, we have been discussing simplification of context-free grammar and how to eliminate useless symbols, how to eliminate unit production, how to eliminate epsilon production. We discussed, and after that we discussed what is the standard format of Chomsky normal form and how we are converting a context-free grammar to its equivalent Chomsky normal form grammar. With that, I am concluding this session. Thank you.